Hi, my name is Christopher Semali, and I'm in Lab Section X09, and this is my Lab 1 video report. Within this experiment, we were trying to use two charged pieces of tape in order to monitor and model the properties of the electric force. We did this by layering multiple pieces of tape along one another and quickly using the sticky side to strip uh, the electrons off of atoms from the bottom layer of tape, as you can see on the right, on the image of the left of the layered pieces of tape. And on the right, we took those negatively charged pieces of tape and tried to determine like a critical separation distance between the two, where the force, where once the where at the point where the force of gravity of the top layer of tape, which is drooping down, and is overwhelmed by the electric force of the bottom piece of tape, which would where if it was overwhelmed, you would notice that the top layer of tape would be levitating slightly upwards, which isn't like shown within this image. Um, these if but however if these and as you can see within the image, I'm also holding these pieces of tape very gently, meaning because if I touch the sticky side of the tape, it would the charge would be distributed throughout my arm because my hands and other objects surrounding it would be conductors relative to the piece of tape, which is made out of insulated material, which keeps charge at a fixed point. And say even like while demonstrating in the beginning, once I rip off the pieces of tape, I would notice that my hand, that the piece of tape would be attracted towards my hand, which would be positively charged relative to the piece of tape. Say if the piece of tape was positively charged, then my hand or negatively charged objects would be attracted to the piece of tape in and of itself, as opposed so the opposite would occur. And now within the immediate experiment, we were trying to determine the separation distance, but ultimately we were trying to determine the excess amount of charges associated with each piece of tape. So with the separation distance, I measured a separation distance of 3 centimeters, which is 0.03 meters, and with that I determined the force of gravity, which was 0.00196 newtons, which at that critical separation distance is equivalent to the force of the electric field by the bottom layer of tape. Um, and I equated those two equations and solved for the total charge associated with one layer of tape. And I modeled these the layers of the levels of the these lengths of tape as point charges in my calculations. And the total charge associated with each piece of tape was 1.401 times 10 to the negative 8th coulombs, which you can see on the bottom left hand side. And from there, I took that total value and tried to find the number of electrons associated with each length of tape, which are evenly distributed along the length of tape. And by dividing the total charge by a unit charge of an electron, which the quotient of that was 8.744 times 10 to the 10. And from there, I determined the amount of atoms along the central length of each piece of tape, which is denoted as A, and which I did by dividing the length of the tape by the dimension of an atom, which equaled 2 times 10 to the 8th atoms along the length of the central tape. And from this, I created a ratio between the electrons stripped from each atom, which reduced down to 4 electrons per atom. 4 electrons were stripped from when trying to charge these pieces of tape, as you can see on the left, when I was trying to do it on the left. And yeah. Then I used my values to and insert them into a computational model, which primarily utilizes the Lab0 templated code, and all I mainly changed was the charge associated with the pieces of tape, which is 1.401 times 10 to the negative 8, and the observation location, which was the separation distance. And through this computational model, I was able to determine an arrow. You could graphically see an arrow which represents the the force associated by due upon by the electric field, and which is equivalent to also the force of gravity, as you can see on the within our previous calculations, and you can see in the bottom columns as well. And that is all. Thank you for watching my video, and have a great rest of your day.